Hello everyone, good afternoon. So yesterday I discussed about the philosophy of research, how the saga of research began few centuries ago, and mankind learned to understand the phenomena occurring around them. Today I will discuss the different types of research that one does in the laboratory or in the fields. And I will try to just give you an overview of what are the different types of research that are usually done, and then slowly converge to the end of this lecture. I will be able to cover the introduction to the research methodology. Okay, so let us see what are the different types of research that one does. I have put a cartoon here which shows 4 quadrants, and the 3 quadrants have something where the last quadrant is blank. So this essentially tells you again the different types, a broad classification of the research being done worldwide. So this you can see the x-axis and y-axis of this diagram. The x-axis is the consideration of use. That means the applicability of that research from left to right, low to high. And on the y-axis, we have the quest for fundamental understanding from bottom to top, low to high. For example, the Bohr's quadrant, top left, was this. It refers to the Niels Bohr's theory of atomic structure, wherein he proposed the model for the structure of atom with the nucleus in the center and the electrons orbiting the nucleus in spherical circular paths, stationary orbits. So that is a pure fundamental research. It does not find any direct application in any area. So this is what is called the pure basic research. But it adds knowledge in understanding the structure of matter. So this is called the Bohr's quadrant, which involves pure basic research. Sometimes people also call it a blue sky research, So the atomic investigation of atomic structure by Niels Bohr, and this type of research comes under pure basic research. Come to the right bottom, applied research. It is in the name of Thomas Edison quadrant. Thomas Edison was known for several inventions. He, in fact, invented 1093 creations. So he has 1093 patents in his name, which include invention of devices in electric power generation, mass communication, sound recording, motion pictures, and whatnot. So in the 19th century and early 20th century, many inventions in the field of communication were made by Thomas Edison, but without any fundamental understanding of how they function. So this is an area of applied research wherein you don't really bother about the fundamental principles behind which these equipments are functioning. That is called as the applied research. And the top right is the Pasteur's quadrant. Yesterday I explained about Louis Pasteur's germ theory, how he understood that the fermentation is caused by the enzymes, and the microorganisms, they get killed when you heat this substance at 60 to 100 degrees Celsius. And from the basic understanding of the germ theory, he gave the process of pasteurization. So the Louis Pasteur is credited with the this quadrant called as the huge inspired basic research. That means you have something in your mind, you want to solve some problem, but you start with the fundamentals. So you do basic research towards understanding of the phenomena that lead to that process, and then suggest the remedies or the solutions to solve that problem. So this is the quadrant, ideal quadrant for research, for a researcher. So both, though the fundamental understanding of the nature is also equally important, and the inventions are also important, but the ideal research will be to do fundamental research, use the knowledge in developing different products and processes. So that is what is the basic and applied research. The same thing I have tried to depict in a different fashion here. The figure is same, except that the x-axis and y-axis coordinates, earlier it was low to high, and it was low to high. Now x-axis is no to yes and no to yes, means consideration of huge, the lower side is no and higher side is yes, and same is on the y-axis. So again, you have the same thing, pure basic research. So you have the quest for fundamental understanding is high, but there is no consideration for huge for the basic research. For the pure applied research, consideration of use is yes, very high, but there is no understanding of the fundamental phenomena. Whereas the huge inspired basic research, the Pastor's quadrant, involves both fundamental understanding as well as the consideration of huge. And so these quadrants are also called as pure basic research as yes-no quadrant, pure applied research no-yes quadrant, pure the huge inspired basic research as yes-yes quadrant. This yes-yes quadrant is also called as directed basic research. That means you have in mind certain applications and you do the basic research. So here I have put a question mark about the no quadrant. And it is a sometimes, it is a tragedy that many of the publications published by the scientists in the modern times come in the no category. So we have to dissuade from that habit of publishing, which neither has a fundamental understanding, neither it adds to fundamental understanding, and not it is applicable in any product or process development. So avoid coming into the no quadrant. So this yes-no quadrant is more familiar than this previous one of low to high. So you see, when you are doing research, always ask yourself question whether by any chance you are coming into no quadrant or not. So you should avoid being in the category of no. As I was mentioning, whatever work you do as a part of your research, you see that it is adding some new knowledge to the already existing knowledge, or it adds some application, some value, some application you find for your work. Sometimes we start in the introduction some application, but finally end up with the no application. So that we should take care. Okay. Now, just to give you a little more comparison of the different types of research. So the fundamental and applied is the same as I discussed previously, but we can try to compare them. The fundamental and applied research, you can see the fundamental research seeks generalization. In fact, any big discovery, you will find it is more general, like Newton's laws. Newton's laws are applicable in any condition. Einstein's laws, or fundamental electromagnetic theory, electrostatics. Whereas applied, they apply to study individual or specific cases. The applied research is confined to a particular application. Fundamental research aims at basic processes that happen, like thermodynamic laws. They are applicable in any system. Whereas applied research aims at any variable which makes the desired difference. So you tweak the parameters to make some use of that particular system. Fundamental research attempts to explain why things happen. Applied research tries to say how things can be changed for a particular application. The fundamental research tries to get all the facts. The applied research tries to correct the facts which are problematic. So you have in mind a particular application and your research is oriented towards that. The fundamental research reports in technical language of the topic. So you use the technical language, whatever understanding is there till that time. Whereas the applied research, there are reports. They are in common language because you want the people to follow it and execute the research. For example, in the fundamental research, you have the molecular biology, how the molecular mechanism of biological activity of a living organism, whereas developing vaccine for COVID can be taken as the applied research. So the fundamental understanding in molecular biology will lead to developing vaccine for COVID-19. So then you can be in the yes quadrant. So you cannot develop a vaccine without understanding the fundamentals of molecular biology. Okay, there are other variants of RM-2144 Akanksha Agrawal requesting to annotate the shared content. Okay, there is another type of research, like, when you will do research, you will find it can fall in this category. So they are not different. Like fundamental and applied is one type of classification. Descriptive and analytical is another type of classification. The descriptive research includes surveys and fact-finding inquiries of different kinds. It doesn't have any control over the variables. So you are understanding like you are doing a survey, like an opinion poll, or you want to forecast the trend in fashion or different areas, shopping, or how the people will do the shopping in 5 years from now, or what is the effect of pollution on health, etc. So these are surveys which you don't have control over the variables, but you just report the facts. Whereas analytical research does a critical analysis of the facts and the information already available. Whatever information is available, you analyze the data to find out the root cause of an analysis of an event, or you can, like, for example, air quality monitoring in metropolis. So these days you must be finding every day you see AQI. So there are some equipments, they are monitoring the air quality, and you get to know next day the newspaper. Analytical research reports include definitive conclusions about the system under investigation. So the descriptive is more general about the facts. Analytical is more about what are you derive the conclusions about how the system is behaving. Then there can be quantitative or qualitative type of research. Quantitative, you all know, it is numerical. Qualitative is not numerical. Quantitative applies to, it uses statistics or mathematics and uses numbers. You get, after the research, you will get some numbers and you will be handling them, you will be doing some analysis. Whereas the qualitative research will apply reasoning and you will use the words to explain, to describe that particular phenomena. Quantitative research investigates what, where, and when of the decision making, whereas qualitative investigates why and how of the decision making. So these are general definitions of qualitative and quantitative. For example, the quantitative research will, like you can say, measuring the mass of a neutrino. So your aim is to get a number. What is the mass of the neutrino? Whereas qualitative is establishing correlation between smoking and occurrence of lung cancer. So you don't get a number. You will say, is there a correlation between smoking and lung cancer? The answer can be yes or no. Yes, with certain confidence interval, confidence level. So these are the different types of research that one do. Then you have the conceptual research and the empirical research. The conceptual research is related to some abstract ideas or theory, whereas you have something in your mind and you want to understand the phenomena, why they happen. You build the concepts. The empirical research relies on experience or observation alone without due regard to system or theory. So you derive some relationship based on some measurements, then find out some functional relationship between the two. That is empirical research. Conceptual research aims at finding explanation of the observed phenomena. So they are much deeper in understanding of the phenomena that are happening, whereas empirical is based on experimental research, which are interpreted by fitting into mathematical models to generate correlation among the various experimental quantities. I just gave you some examples, like, if you want to know what causes the diseases, like, for example, Louis Pasteur wanted to know what causes the fermentation. So it is you develop some concepts based on your research. Similarly, what are the fundamental building blocks of matter? You develop earlier it was electron, proton, neutron. Later on it became the quarks and leptons. So the concepts are changing with time as we advance our knowledge. Whereas the empirical research will be, now you make a model how the population is growing in different countries. What is the rate at which you must be knowing down the fertility rate, and see how the different countries the population is changing. Like another one very interesting work is the per capita electricity consumption and the female literacy can be called as the developmental index of a country. In fact, Dr. Chidambaram, our former chairman of AEC, proposed this kind of correlation. The different countries can be classified in terms of their per capita electricity consumption and the female literacy to see the level of development in those countries. So there was a fair amount of correlation between these two. So you essentially draw empirical relationship. There may not be any direct mathematical formulation to understand these correlations, but they do indicate a trend. That means if a country has higher female literacy and higher per capita electricity consumption, the index of development is higher in that country, or even you can say in India in different states also. So that kind of research also people can do. Okay, so this was about the different types of research that one does. Now I'll come to the actually, in fact, whatever research you will be doing as a part of your PhD, you will find that you will fall in one of these particular categories. There are 6 categories which I have listed. I'll just explain them in one by one. So these are also type of research, but these are more on example basis. Like in the laboratory, it can be of all the types. Whatever I have discussed so far, they can fall into these 6 categories. For example, like I mentioned, quantitative and qualitative measurement of a value is a research. It will fall in that quantitative way. So a different type of research that I'm going to describe now, they will fall in one of them which I discussed so far. Then the first and the most well-known research is called hypothesis-driven research. In fact, majority of the cases you will find when you are doing research, you have something in your mind that you expect this kind of thing to happen. And then you start working, you're planning your research to see whether that assumption or hypothesis that you have made is true or false. So this is called the hypothesis-driven research. So what is a hypothesis? A hypothesis is a statement about the world, about anything, that can be true or false and whose truth is being tested. So you want to investigate whether this hypothesis is true or false. So you make a statement, that is the hypothesis, and you do experiments, and then you analyze your data and finally come to the conclusion about whether the hypothesis is null or not, it's false or true. So that is the kind of research one does, and we will have many such examples in the subsequent lectures on hypothesis-driven research. This is only for the sake of the introduction. A valid hypothesis must be falsifiable. In fact, you have to plan the experiment in such a way that either the hypothesis is false or true. Meaning, we should be able to show it to be false. If it is not false, then it is true. So it has got two options, like two sides of a coin. Either it is head or tail. So the hypothesis-driven research has this kind of final outcome. You start with the hypothesis. For example, as I was mentioning, the smoking causes lung cancer is a hypothesis. And how do you confirm this hypothesis? You do a survey of people who smoke and people who don't smoke and find out a correlation of the people, how many people, how many of them, how many people have lung cancer. Among the non-smokers, what is the percentage of cancer people? So then you do the analysis and finally come to a conclusion with a certain confidence level that yes, does smoking add to lung cancer or not? So you can make a final conclusion based on. There is one very interesting example about this smoking causes lung cancer. Later on, I hope it will be covered in subsequent lectures. For example, one of the interesting hypothesis is aspirin cures headaches faster than brufen. So aspirin and brufen are two medicines used for cure of headache, and one wants to study which one is having faster effect on curing of headache. So you have to do an experiment. We can check by using the two drugs on randomly chosen populations who are suffering from headache, and you try to derive some conclusions of that research, that whether this hypothesis is valid or not. So there are several examples of hypothesis-driven research. You try to associate this with your own work. Some of you, if you have started working in the laboratory, you can try to associate this with your own work, whether it falls into that category or not. The second type of research is measurement of a value. Many of the research is aimed at finding out a particular value. Like, in nuclear physics, we do cross-section measurement. You want to find out the cross-section measurement or the half-life of a radioisotope and so on. Mass of an electron neutrino is a research where it comes in this category. Like measurement of mass of electron or charge of electron, it comes in this category. So all experiments, in fact, just to tell you that the neutrino is considered to be near zero mass. So whatever experiments have been done worldwide, they concluded that its mass is too small to measure. But experiments are still going on. Even in India, you have a Indian Neutrino Observatory coming up to measure the mass of neutrino. So if you have, even if it has a milli-electron volt as a mass, that has got a great implication for the total amount of matter in the universe. So these neutrinos are emitted during beta decay, beta plus or beta minus. And so there is a lot of research using in this area where people are interested in finding out the mass of a neutrino. Similarly, you have a research wherein you establish a relationship or a function between, you can have I think somebody's audio is on. You have to unmute. Okay. Yeah. So this is another very common type of research that one does in the laboratory. You measure a function or a relationship. Many of you may be working in this particular type of research. For example, find the effect of a fertilizer on the yield of potato per hectare. So how many, like this many, 1,000, 1 ton per hectare, no? So it is a number, and you have the how much fertilizer you add. So you add some quantity of fertilizer and measure the yield of potato per hectare and draw a correlation, the potato per hectare versus yield, the fertilizer quantity. So you can derive this relationship. Or for example, 1 by R square law, the dose from a radioactive source, the dose is decreasing with the distance as 1 by R square. So one can experimentally verify this relationship by taking a source of gamma ray and changing the dosimeter, the distance between the source and the dosimeter. You can change the distance and find out whether 1 by R square law is applicable, valid or not. So there are, in your research area, you will find certain research will fall in this particular category. The fourth category is construct a model. It can be most of the time, in theoretical science and applied mathematics, they will be working on this type of research. For example, if you want to predict the rise and fall of population in countries, you must have seen today or tomorrow, that yesterday, that China has peaked its population, and compared to 2021, then its population has decreased by some 850,000. Now, there are predictions. People are predicting the population of different countries. As you must have read some time back, that India will be the most populous country in very immediate future, maybe few years, couple of years from now. So that is all based on the models. So people are doing this population science. Population science is one area where people are working. Another thing is like the climate change effects. To reduce the global CO2 emission. Global CO2, there is an agreement between the different world bodies that we have to reduce the carbon dioxide emission to zero by 2050, and so that the global average temperature rise is restricted to 1.5 degree by that time. Otherwise, it is expected that it will rise by 2 to 3 degrees. So this global warming is a very dangerous trend, and you must be seeing the effect of global warming even now. And so all the humanity, or particularly the scientists, are worried how to apply brake to this. So one of the options is that you reduce the emission of greenhouse gases so that the temperature rise will be less. So this also there are models. So when one is predicting that by 2050 we have to cut down the CO2 emission to zero, how they will, there must be some model people may be working that by this we can restrict the temperature rise to this. These are the kind of research the climate change scientists are doing. Then there are research on observation and exploration. There many people, in the social sciences will be doing this kind of research, or even for that matter in sciences also. One of the examples is measure the chemical composition of Everest ice cores as a function of depth. So this is a research problem by the environmental scientists, that you go to the Everest, drill, make a drill, collect the core samples of the ice, and find out the chemical composition of those ice core samples. What is the use? It will provide the annual information of climate and chemicals in Earth's atmosphere going back hundreds of thousands of years. See, when the snowfall is there, along with the snow, the environmental pollutants are also deposited. And so, if you do the composition of this ice sample, you know how the pollutants got deposited, and then you can try to predict the rate at which the pollutants are generated. Similarly, the sediments, the sediment in the sea, in the coastal area of the sea or the lakes, the sedimentation rate can be measured by drilling the sediment samples and measuring the radioactivity of lead to this polonium-210 or lead-210 to find out what is the rate at which the sedimentation is taking place. Similarly, the extinction of living species, how the evolution is taking place. Many living species are getting extinct over a period of time. You must have seen the vultures, the vultures, it is believed that they are getting extinct. Even the sparrow that used to visit our homes, they are very few in numbers. So the biology people are studying the evolution of the species. And very recently, I read to about 2 weeks back that many insects are also vanishing, and they are the indicator of the climate change. The last one is the improve a product or process. Many of you might have got this kind of a project, like you create a to convert energy of radiations emitted by radioactive substances into electrical energy. This is called as the thermoelectric devices. The radiations are generating heat, and that heat you can convert into electricity. Thermoelectric devices. See, these radioactive sources of plutonium-238 or strontium-90, they are long lived, and when you put it in a device called thermoelectric device, the heat that is generated you can convert to electricity. And in satellites, you can put this plutonium-238 having half-life of 85 years, and it will power your satellite. So low power sources, like in pacemaker. In the pacemaker, people who have some cardiac problem have a artificial system to revive the heart. So that pacemakers have the small radioactive source. It will give the energy required for your pacemaker. So this kind of developments all come into the making a product. Like digital payments these days, how we are using our digital payments. So it is so common to make payments through digital platforms that somebody must have developed this processes. So they're all, whatever you do, probably you'll find it has come out of the research being done by numerous people and over a long period of time. Okay, so these were some of the examples of different types of research one has done or one would be doing in the laboratory, and you can associate yourself with one of them. Okay, so what is the importance of research? Some of it I discussed yesterday. Let me repeat. So the research is the fountainhead of knowledge and provides guidelines for solving problems. So whatever knowledge that is generated over a few centuries now, maybe hundreds of centuries, we have accumulated that knowledge and we are using it today so easily. So it is available to all the mankind to make use of, and that is how we solve the problems. Research on existing theories and concepts helps us identify their applications. Many research is done at that time. There is no immediate application, but subsequently you will find it is being used. One of the classic example is www. The www, World Wide Web, was developed by scientists at CERN, Geneva, who were doing experiments on high energy physics. And whatever data they were generating, the experimenters are from different countries, and they wanted to send the data to them to analyze. So they developed this www, and now it is a household name people use in so commonly. We use www. So at that time they did not think of that it will become so popular to the common people. Research provides basis for many government policies, like research on needs and desires of people, availability of revenues to meet the needs, help a government to prepare a budget. For example, these days our finance minister Nirmala Sitharaman will be very busy how to prepare the budget. But in that budget, the input goes from all over the country. There are economists giving inputs, what is the requirement for the mankind in terms of the health care, education, food, so many things. These are all based on research. So several people are busy doing research. Research is also important in industry and business for higher productivity and to improve the quality of products. You must be seeing different, same product made by different companies. They tell you their product is having superiority over the others in terms of certain things, the cost, the quality, the efficiency, and so on. So industries are doing research continuously to improve their product. It leads to identification and characterization of new materials, new living things, new stars, etc. So discovery of different, you still even now you'll see how the neutron stars, supernova, and the black holes, everything. So many discoveries are taking place by this research. Research leads to new inventions like computers, supercomputers, cloning, smartphones, vaccines, etc. You name a thing, and it has come out of research done by somebody. And finally, in society, it helps to find answers to our social problems. So it is there. Research is all pervading. Whatever you are doing has come out of some research. So what does this research mean to different individuals? Yesterday also I discussed this. To students like you who want to obtain a PhD degree or MTech, research may mean career or a way to attain a high position in social structure. You want to know, we call it as a doctorate in that particular area. To professionals in research, it is a mean of livelihood. We in DAE did PhD because it was a part of our research, our profession. To philosophers and thinkers, research may mean the outlet for new ideas and insights. To literary men and women, research may mean development of new styles and creative work. Fashion, many, or in literature, many concepts are developing over time. To analysts and intellectuals, research may mean generalization of new theories. So, the great intellectuals will try to see generalities in different laws and come out with a new law. So these are also research only. Everything people are doing, depending upon the subject, depending upon the level of an intellectual, they do research in different frame of reference. Okay, so now coming to your PhD program. Most of you are PhD students, so you are doing research for a degree, and later on look for some employment elsewhere. Some of you are already employed in the department, and you may be, as a part of your career advancement, you are doing PhD. So PhD degree is an important milestone in the career of a scientist. During PhD, one learns how to pick up a research problem. So this PhD of 5-6 years is a training to do research. How you do research, this is the time for you to learn how to carry out research. You are learning how to extract new information from the results and how to publish the findings to the scientific community. So this research methodology course actually is to prepare you to do a research in a very systematic way, so that you learn, you do the things in the best possible manner. It is the stage where the values, traditions, and style of science are transmitted from one generation to another one. So when you join a particular laboratory, particular department, the seniors in your laboratory, the head of the department, the professors, or the senior scientists, you start them, you learn from them not only the how to do research, but also that language of that topic. So you discuss with them, and through the dialogues, through the discussions, you learn. In fact, you imbibe the habits also of your bosses. Sometimes you find over a period of 5-10 years, you start speaking in the same tone as the guide or the senior sweating. So this is the gestation period for the researcher, where you you imbibe those traditions, and that is where people try to go to a laboratory where the best people are there in research. So you learn the best. So you must be seeing many of the institutes in the country, IISc Bangalore, TIFR. People rush. Why? Because they have maintained certain standards. Everybody wants to go to IISc Bangalore, TIFR, or even for that matter, DIRC, or many such student institutes. So that the mark of that institution is left on you. How it is measured? You learn the basics of what kind of research you do, the standard of research that you do, the kind of equipment that you handle, how do you arrive at the conclusions, how do you interpret your results. All you learn from your guide, from your seniors. And this is the time that when you are doing PhD, you imbibe those traits from your seniors. So this is the time, make use of the most of it, whatever time you spend. So I was telling yesterday, 8 hours not sufficient. Spend as much time as with your seniors so that you learn all these traits. And that is why, to make it in the research more, in a very successfully carry out the research without losing much of your time and effort, the research methodology course is being proposed to you. UGC also has, they have been thinking that how the research, how the students should be making best of their laboratory facilities, of the literature, and so on. So what is research methodology? Research methodology is a way to systematically solve the research problem. So you have been given a problem by your guide. What is the best way to solve that problem? You learn if you know research methodology. It may be understood as the science of studying how research is done scientifically. So it is not necessarily science. So studying how research in any area, it is humanities or mathematics or physics or biology, any area, how scientifically to do research, you learn by using this course. It is also defined as the study of methods by which knowledge is gained. So how to gain? You have a vast amount of knowledge around you. These days, even a young child tells parents, Google kar lo. The child also knows that Google knows everything. But you know that Google has, whatever is there in Google is not authenticated. So you have to be very careful when you do a literature survey. Later on, Professor Naik will explain that you have to be very careful in accepting from Google. So you have to go to the platform which is having authentic information. Research methodology encompasses the procedures by which researchers go about their work of describing, explaining, and predicting the phenomena. By following proper research methodology, we generate ideas, concepts, data, which can be evaluated and validated by others. So, whatever research we are doing, we generate some data and how to report them, how to do statistical analysis, and how to report our data so that others can repeat those experiments and validate. So that is what is research about it. It also helps save time and effort. Many times, you are doing some research, but later on you realize after 1 year that you have not been doing the things rightly. So you can save that time and effort once you know what is the way to go. Sometimes you get lost. The problem is not properly defined, and then your time is gone. So this will help you in cutting those inconveniences. So research methodology means in this research methodology course, you will also learn about different research methods. So research methodology is a broad concept. It is a subject to study, and research methods are the tools that you employ in doing research. So research methods are various methods or procedures or schemes and algorithms that one uses in research. So these are theoretical calculations, simulations, or experimental sample surveys. They are essentially planned, scientific, and value neutral. Means they are general tools they don't have any value. But like numerical analysis, you can do numerical analysis in any area. You can do any experiment, any survey you are doing on any particular field. So they are planned and value neutral. Research methods include theoretical procedures, experimental studies, numerical methods, statistical approaches, etc. And that is why you will find that this research methods part, it's different types of instrumental techniques, different types of modeling, simulation, they are the part of module C. The module C, or we call it now part 2, will be taken in your own institute, because different students will have different requirements. Some of you are doing theory, some of you are doing mathematics, some of you are doing experimentation. So this module C includes different research methods, and that will be varying for you. So this will be taught in your own institute by your seniors, and that will be the module C. We are taking care of the general aspects of research methodology and ethics in publication research. So research methods include collection of sample, measurement of the sample, data collection to find the solution to a problem. So these are the different research methods. Okay, so what is the scope of research methodology? Research methodology and research methods. Research methods is a part of research methodology. The scope of research methodology is much wider than that of research methods. Or we can say research methodology encompasses the research methods as well as the logic behind the methods we use in the context of our research method. So when we use a particular research method, then research methodology justifies that why you use this method. So it is a part of research methodology. When you are justifying why you are taking this as a tool for solving this is a part of research methodology. Research methodology helps in answering the following question, like why a research has been undertaken. Actually, these are the most important aspects when you are doing. If you ask these questions to your guide or to your seniors, they may sometimes feel offended, but they are very important questions too, and you should be very clear in your mind why we are doing that particular one. So why a research has been undertaken, if you should be able to answer this. In what way and why the hypothesis has been formulated. If it is a hypothesis-driven research, why this has been, in what way it has been formulated, what data have been collected, what particular method has been adopted, and why a particular technique has been used. So if you know you are very clear about this thing in your mind, then your research, whatever you do, you will find you will have some meaningful outcome of that research. Okay, so research methodology is a very important aspect of the research work that one does. The study of research methodology gives the student the necessary training. This is out of none. That is why within 2 years you are supposed to complete this course. That when you start doing after your credits are earned, then you start doing research. So before you start doing experiments in the laboratory, you need to know about research methodology, because this is this prepares you, this gives you a training in gathering information and materials and arranging, indexing them. So literature survey, how to do literature survey, you will learn is a part of this research methodology course. Where to look for the particular information and how to get that information. Participation in the field work when required. So people who are doing the sampling, the agricultural areas or different types of, even in the the opinion poll, people are going to different states to finding out which party will win. They are doing a lot of field work, and also training in techniques for collection of data appropriate to a particular problem. So how to collect the data, how to do sampling, all this is trained in this part. Use of statistics and controlled experimentation, and in recording evidence, sorting it out and interpreting it. So Statistics is a very important part of research, any research. So when you are doing some hypothesis-driven research, you are arriving some conclusion, then there will be some statistics involved. For example, when you say smoking causes lung cancer, it is not that it is yes or no. With certain confidence, what is the confidence that you have generated? So with 90%, 95% confidence. So you will see these numbers coming up when you do the analysis. And of course, this is also helps in effective communication of the findings to the other researchers. So you will also learn how to write a paper, how to write a thesis, and how to do an oral presentation when you attend a conference. So effective communication is a very important part of the research methodology. And so you will also learn how to make a effective presentation to your peers in a conference. So these are all the different why research methodology is so important. And then lastly, so ultimately, what are the different components of research methodology? This slide gives you the last different components. And in fact, it is in a sequence. So you will see your entire research PhD work will be involving all these aspects. Not necessarily all this, because depending upon the type of research that you do, but at least few of them are very common. For example, the first and foremost thing for you to do is to formulate a research problem. So how do you identify what you should do as a part of your PhD? So you have to formulate the research problem. Your guide may give you a broad canvas, it gives you a broad canvas, like these are the equipments in my laboratory, these are the samples in my laboratory, and you have to work on this. So you have to choose which equipment, which sample, which system, and all that you need to do a lot of literature survey. So the second part is the extensive literature survey, and that will help you in formulating the research problem. So once you have done literature survey, once you have, then based on that you formulate a research problem. Then based on if it is a hypothesis driven research, you develop a hypothesis after these two, first and second, are done. And based on that, you prepare a research design, whether you will do numerical analysis, statistical analysis, sampling, or theoretical calculation. Whatever you do, you prepare the research design. Then as a part of that, then you may have sample design or simulation. You depends upon what kind of research you are doing. You may be collecting some samples, or you may be preparing some samples, or you may be doing some model, some theoretical calculations, you make some code. Then once you do that, you collect the data. You collect the data from your instrument. You have chosen which instrument you will use, which sample you will analyze, and then analyze the data. And the moment you do analysis of data, statistical treatment is a must. So any number you quote, you must have plus minus on this. Many times we see some papers, people are not writing plus minus. The moment you do a measurement, there are bound to be uncertainties associated with that measurement. So statistical treatment is a must for data analysis. And after that, you analyze, you do the hypothesis testing. If it is a hypothesis-driven research, then you generalize and interpret your outcome. Once you have done that, then you start writing the research paper, send to a journal, then you submit your thesis, and at the same time, you present your findings to different platforms like conferences, divisional seminars, and so on. So this is what is the different, you will be learning all this as a part of this course. And in addition to this, you will have the associated with this is the ethics. Ethics part will be taught by Professor Siriguri. And also, that in fact, it is now being encouraged that whatever, if you are doing some invention, then you must do patenting of their work. So patenting and intellectual property rights also need to be learned. So this is what you will learn as a part of this course. So thank you. And if you have any questions, then you can ask me in chat box. Any questions from the students? No, they can type in the chat box. You can unmute also. If you can raise your hand here, and we will unmute you if you want to ask. Those who are on WebEx can do that. There is some hand here, no? They have to raise hand. How do you know? Huh? Color checking. Color checking. So you can ask those who are on WebEx can raise your hand and ask question, or you can type in the chat box. Yes. Can these slides be shared with us? Yes, definitely. We will share with you the slides. We have in Anuvidya portal, we will be posting these PPTs. Either hai na? You have the in your desktop, no? You can post in that. They will be posted in your. Sir, can these slides be shared with us? You can download from that Anuvidya portal, I think. I will find out, but you first watch them in your Anuvidya portal. We will be posting this PPT in that Anuvidya. And you have access to Anuvidya all the time. Good. Any other question? I haven't received my login ID and password yet. Devkanta Ghosh. Can you write the name? Devkanta Ghosh. You can send a mail. You can send a mail to Professor Nayak or me. You have my email ID, I suppose. Our help desk at hbni.ac.in. You can send mail on this. Any you have any query regarding this course, you can send a mail to helpdesk@hbni.ac.in. But these are all questions of administrative type. I was expecting some scientific questions, No questions. Not yet. Okay. You can write to me also by mail in case you have any query subsequently also. Any question before that? No. Atanu Jha for today's class. Atanu Jha, you have to write your registration number. See, you have to write your registration number in place of, instead of writing your name, you can write your name followed by register. Like people are writing RM-2 So you write that 4-digit number, RM followed by 4-digit number. That is your registration ID. So all the students should write, because that will be used to generate the attendance. So please do write your registration number in the chat box. And if you do not have the registration number, then immediately write to help desk that it is why it is not there, and you can be generated. Yes. So he has a registration number. Good. Okay. Okay. How we know our hypotheses are correct or wrong? That's a good question. So when you see, I will, in fact, tomorrow's lecture, I will discuss some of the examples of a valid and invalid hypothesis. So a hypothesis which cannot be falsified is not a valid hypothesis. And so we have to, that is a way to do that analysis, whether the hypothesis is valid or invalid. So I will discuss that tomorrow. Lecture was quite clear. Okay, thank you. What is your area of work? Good question. So my area of research is nuclear and radiochemistry. My I did MSc in chemistry and then worked in nuclear chemistry. So my specialization in nuclear and radiochemistry. Can improving a product lead to publication? Yes, very much. If you improve a product, see, it will be like a patent. You can make a patent. And whatever you do to make a patent, you can also publish it. Now, and you know, when you have made an invention, this is like an invention. So you first patent it and then publish it. Till the time you patent it, you can keep on hold that publication and then immediately publish it. Good question. All these things, you know, Professor Ganguly is an expert on this, and he will discuss about publishing your results, which can lead to a patent. Good. So, what is the time? 5:06. Okay, so I think we will stop here. And you can still, if you have some questions, you can write to me by mail or to Professor Naik. Okay, we'll see you on Friday. Okay, bye-bye.